All right, so welcome everybody to the Silicon Valley JavaFX user group. So how many of you are here for your first time? Okay, 2 new members. Everyone else are veterans at eating good pizza. So we meet approximately once a month, although most recently it's been about bi-monthly on JavaFX topics. I'll give Rich the stage in a sec. He's going to talk about OpenJFX, which is the open sourcing of the JavaFX 2 code line, and a little bit about what they're doing with their Gradle builds. They've been internally converting over everything to use Gradle and have some good experience with doing a large project in Gradle and some of the interesting stuff they hit. So if you're a committer, then this is all great stuff because you're going to have to deal with it quite soon. A little bit about our sponsors for the group. So
this is not projected.
This is not projecting. Once this is projecting, people in the room here will see what's online. So Oracle provides the venue and also the food for the evening. Linode provides the hosting for our website and some other related open source JavaFX projects. We broadcast the live streams on Ustream and also UBevent, although not recently. That's more for archival purposes. JFrog's been helping us out with meetup fees, and then we get a bunch of book sponsorships. Yeah, that should be fine, mirroring. So book sponsorships from A-Press, O'Reilly, Manning, Pearson, other folks. And also JetBrains, you're set up in yeah, set it back to mirror. And also JetBrains is one of our sponsors, so one of the attendees in the room here will be getting a IntelliJ license at the end of the session. Ooh. So we'll hold a drawing. One lucky attendee.
Yeah. Which now supports JavaFX.
Oh yeah, as of the most recent patch of IntelliJ, they now have first-class JavaFX support, so we're very happy. Apparently, we must have something to do with it because we're a JavaFX user group and we give out IntelliJ licenses. So they probably figured it was embarrassing to give all the JavaFX guys IntelliJ licenses and not have good built-in support with Scene Builder and everything mixed in. Okay, and there's the website for the group. For those of you watching live, we have a chat window open. We're only going to be monitoring the chat on the Silicon Valley JavaFX user group, even though we're broadcasting to both the Jug channel and also the Night Hacking channel. And feel free to ask questions or comments, and we'll hit Rich up at appropriate times or towards the end with what the online questions are.
Probably just about any time.
Okay. So as stuff comes in, we'll let you know. Any good heckling, we'll fill you in.
Yeah. But you have to do it in character.
Yeah. I'll let Keith do the impressions. All right. So floor is all yours, Rich.
All right. Well,
I should have introduced who Rich is, for those of you who don't know. So Rich is JavaFX Chief Architect.
Java Client.
Java Client Chief Architect, works for Oracle. And if you've been on the OpenJFX mailing list or been involved with JavaFX over the years, he's been at the center of all the interesting architectural change which has been happening on the platform. All right, so all yours, Rich.
Okay, thank you. I'm going to bring up a couple, I guess, important websites about the project, just to kind of show a little bit. Before I've got some slides to talk about the build and test, but I'm going to start off just talking about the project in general, the open source project, and so you kind of get your feet wet in terms of I don't know, some of the main websites and things, and so you kind of know how to follow along as to what's going on in the project. So this is our main project page. And, or at least it's our home on OpenJDK. We don't have a whole lot of stuff there. For the most part, we just redirect to the wiki because the wiki is a lot easier for us to update and maintain than this web page is. So this is if you just go to openjdk.java.net, and it has all the different OpenJDK projects, and OpenJFX is one of those projects. You can see it here on the list. Small text on the side. It's one of the many OpenJDK projects. Being a part of OpenJDK, we have all the same Governance, bylaws, structure, and so forth is the rest of the JDK. So on the OpenJDK page here, it has a list of some things on the side that might be interesting to you, one of which would be contributing. So if you go to contributing, you'll see that there's some text here on how to become a contributor. Basically what it is that there's an Oracle contributor agreement that you have to sign and send in, which gives us joint copyright on the contributions, which is pretty common these days in most large open source projects run by corporate. Next step is just find something interesting to work on, get onto the right mailing list, submit patches, and so on and so forth. So I'll show you some of the other links, but this one, just openjdk.java.net/contribute, has the information on how to get started. Let me go back to the main project page. This is the main resource, I'd say, right here. It's the wiki, which is pretty nice. We just recently got it in the last 3 or 4 weeks, maybe 2 or 3 weeks. It's public now, and the OpenJDK has pretty strict definition of different roles of contribution to the project. There are those who can contribute source code, which is the hardest level of contribution to get to, and it requires showing some sustained investment or involvement in the project. One of the easier ones to get is the author, and you have to be an author in order to edit the wiki. It's not that hard. A couple weeks of good patches that you send in to update the wiki or articles, or even just being really well known in the community, was good enough to get authorship in the project, in which case you'd be able to come into the wiki and edit it. So there's a few things that we've got on the wiki. It's still pretty fledgling, I'd say, like really pretty fledgling. Some of the sort of things that we want to put on here in the future, for example, we've got information on some of the different features. For example, the tree table view is a new API that's added in Java 8. And so it's got user experience documentation, for example, that shows screenshots or mock-ups of what the component should look like, how it should work, how it's designed, and so forth. So our user experience designer is going to be putting all the different UI controls design documents up here on the wiki, for example, so that people in the community can see how the thing was designed, and if you want to help contribute or work on different parts of the components. There are things that are defined in the spec, for example, that were never implemented because of time or resources, and so you'd be able to come and contribute those sort of fixes and so forth. So anyway, this brief look at the wiki. Probably the most important thing when getting started is the Building OpenJFX wiki page, which is reasonably up to date. Right now, the main way that we build is with Ant, and we're migrating to Gradle. So at the present time, you can build with either. And in the few weeks' time, hopefully we'll be able to work our way off of Ant, and we'll be on Gradle full time. So it's a reasonably comprehensive page that has a lot of information, both in terms of how to build the thing and how to run the builds that you've produced and so forth. So this is a good resource that's out there. The next, I guess there's 2 more, well, 3 more, I guess. These are all pretty critical links. The mailing list is just a OpenJDK mailing list called OpenJFX Dev. We have just the one mailing list at the moment. And we'll branch out and have some more mailing lists when the traffic becomes such that we need to, but at the moment it is working really well, I think, having the one mailing list. So we have virtually all the technical discussion either in the JIRA issues or on the mailing list. And the mailing list is a great place to come if you're interested in actual development of JavaFX. If you have questions about how to use it, the best place to go is typically the forums down here, the OTN forums. And there's some really great people in the community who answer all the questions, usually better than I could, on the forums. And so it's you can subscribe to it and get mail whenever you know, comments, questions, and so forth come through, or you can just go browse and put in your questions, whatever you want. But the OTN forums are a really great resource. So that's more of a place to go if you're using JavaFX and you have questions how to use it. OpenJFX Dev is where you go if you're interested in actually developing on the platform. And then our bug database. Now, our bug database is, I'd say, maybe a little bit annoying because you have to have a login in order to get into it, but anybody can get a login. You just go and get your information and, you know, register, and in you go. And it's a Jira instance, so if you're familiar with using Jira, you can find your way around our bug system and find out, you know, everything that we've got. So anyway, that's the other most useful place is Jira. We try to keep Jira as the one truth. So the state of every bug that's assigned to this release, whenever they're fixed, the discussions that are had, links to the change sets and all that sort of stuff. We try to keep all that in Jira so that that's the one place that's always accurate. And then, you know, on the wiki, we'll have links to Jira issues and so on and so forth in order to keep up with that. So in a nutshell, that's sort of where we're at on the project. Steve Northover and I are in the beginning stages of doing a revamp in terms of how we structure the OpenJFX project so that it's easier to find your way around and contribute to things, and so that we are effectively using all the open communication mechanisms for all the stuff that we talk about, so that, you know, everybody in the community is on an equal level with the rest of us who are working on the closed bits. Now, one of the biggest things that we've been doing in order to get everybody else on the same level is obviously open sourcing code. I'm going to show you this. This is because this is like totally not intuitive. We've got this horrible thing here. Okay, so OpenJDK is all based on Mercurial, right? So I'll go to RT. So here's what you get when you click on the link and it takes you to our Mercurial repository. It's basically hopeless if you wanted to just browse around. It just lists the most recent change sets, and if you click on one of those change sets, it'll give you, you know, a nice little diff in terms of what happened. But if you just wanted to browse, not so handy. You have to click this little manifest link up here. It's probably like 1.5 years of using the thing before it was pointed out to me. I just figured it didn't support the functionality because, I mean, it's not there, right? But yeah, you got to click the little manifest guy, and if you click the manifest guy, then you get a whole directory listing, and it shows you all the different bits and pieces that are in that repository. So we have, over the course of the last year, really about a year and a half, been open sourcing all the bits and pieces, and we're close to having everything open source. The last remaining bits are some Java files related to media, Java files related to WebKit or WebView, and fonts. That's just about it. Pretty much everything else has been open sourced. The font engine that we use is the same one that was used for Java 2D. It's called T2K. It's proprietary, and that's why we couldn't open source it. So we're replacing it with an open source font engine that we hope to be able to use also in the final JavaFX bits. So right now, if you're familiar with OpenJDK, there's the font engine that's shipped with Oracle JDK and JRE, which is this proprietary T2K. Then there's the open source one, which is only used by OpenJDK builds, but not by the closed JDK builds. So we wanted to avoid that in JavaFX, so we're hoping to be able to just migrate off of T2K and just have the open source bits and use that for closed source as well. So we'll be doing performance analysis and some other things like that to make sure that we can do it. But we're pretty confident that we'll be able to move off of that. So our goal is to completely develop every last bit that goes into the JavaFX that we ship to be based on open source bits. So there won't be any of this half open, half closed business ever again. So most of this stuff has been open source, like I say. It's actually a significant amount of code. I counted it up once, put it on my blog. I don't remember what the line count was, but it's fairly significant. There's a lot of code involved. So anyway, I wanted to point out where you can see what the different pieces are that have been open sourced. We've open sourced all the what we call glass, which is our windowing layer. So if you come up and see this little guy glass, he's if we were to drill into this thing, you'd see that there's a GTK, iOS, Lens, Mac OS, and Windows versions of glass that we've open sourced so far. In Decora is all the effects, all the hardware accelerated effects and so forth, and we have a bunch of different implementations of it. So there's a D3D version of Decora so that you can run on Windows, ES2 for running on OpenGL. JSW is the basically Java software implementation, which is if you're running on a platform that is basically hopeless, then you run that one. The pixel shaders, software loops, we have an SSE version of Decora as well, so that if you're running on pretty much any piece of modern hardware, then it'll use the SSE intrinsics in order to get some better native performance for the effect loops. But it only uses those if it can't use D3D or ES2 for some reason and so forth. So anyway, that's what Decora is. And then down at the bottom we have a bunch of Prism. Prism is the name that we gave to our graphics library. So this is all the different backends for iOS, Mac, X11. EGLFB and EGLX11 are for embedded systems, ARM devices, D3D, and so forth. So all the different backends are based on, it's all Prism. Some of them, like Prism Null, we don't actually ship, but it's used at development time in order to do performance testing. So what it does is it stubs out all the graphics drawing so that when you're doing performance analysis, you can say, well, if graphics were free, what would my frames per second be? Well, you can run with the null pipeline, as we call it, and find out. So anyway, there's a ton of stuff in here. Obviously, most of this stuff are things that people wouldn't pay any attention to unless they were hacking on the platform. But that's the point of my presentation tonight, is to talk about what it takes to hack on the platform. So one of my goals with JavaFX is that somebody will be able to go from irritated to patch in as little as a half hour.
Let me
yeah.
interrupt you for a sec. So we had a question on the stream. Hold on a sec. My mic is not working. Oh, don't yet.
And that would be a very simple patch, but should be possible.
All right, so we had a question on the stream from Raj in Chennai, and he was wondering if the OpenJFX bits get rolled into OpenJDK builds.
Yes.
On a nightly basis?
No, it's once a week, I believe, that we take. So the way that we have it set up is that we have several different forests. There's the master forest for OpenJFX. And then there's a graphics forest and a controls forest. Media and web doesn't have its own anymore. Media still has its own. But anyway, so there's several forests. Once a week, the controls forest is synced up to master. And once a week, the graphics forest is synced up to master. And then they sync and sync and sync, and then everybody's in sync. So once a week, you get the master in sync with what everybody's been doing for the previous week. Promoted builds are made from that. They're tested. If it's good enough, then the promoted bits are sent to the OpenJDK guys, which they use to, or with the JDK guys, in which they create the bundles. So actually, I don't think with OpenJDK the bits are moved over on OpenJDK. I think it's just for the actual Oracle JDK JRE bits where we co-bundle.
Okay, yeah. So if you wanted to get the latest OpenJFX, you should download that from one of the builds on the OpenJFX site, and then use it together with the latest OpenJDK build.
Yes. Yeah.
Okay.
So I mean, the easiest place to get, let's see, what's this thing called? It's called jdk8.java.net. And so if you come here and go to the JDK8 snapshot release, accept the stupid the license, and then come in and say, I'm on Mac, so I'll download the JDK. It's gonna give me a darn DMG. I'm gonna open it up. It's got an installer. I run the installer. It sticks it on my system, and when it sticks it on my system, you will have build 87 of the JDK plus JavaFX. So you can, if you just want to run the latest JavaFX, this is the easiest way to get it, the latest promoted. If you want to run the latest and greatest, then you'll have to clone a repo, do your own build, take what you've produced, and combine that with a JDK of your choice. It could be OpenJDK or any other. It doesn't matter.
Could you rip it off the Hudson builds?
No, Hudson's not open.
Okay.
Yeah, so can't get it off of Hudson yet. So we're working on, and this is the bulk of my discussion tonight was going to be on the build and test system for JavaFX. We're working on a lot of infrastructure work for both JDK and JavaFX right now. And one of those things will be a place where you can get regular, continuous binaries. So I don't know if in the final thing Hudson itself will be sitting up there, but there will be some Artifactory or other binary repository available that'll just have all the latest bits. And that'll be the most convenient way to get it if you aren't doing it this other way. But that could be a long ways away still. It's a lot, in corporations, things don't move as fast as they do in other places. So, but that's what we're working towards. So I was saying that my goal is that you could go from irritated to patch in a half hour. Now, if we're talking about like a patch to Java docs, I think that's a reasonable goal, something that you want to be able to do. Now, there's a couple big hurdles to get over in order to make that work. The first thing is, well, at least you need to be on broadband, because otherwise cloning the repository is just going to take too dang long when all the WebKit sources are out there. But right now, for me, a fresh clone is, maybe 5 minutes on the worst side. So it won't be that bad. It still fits in my 30-minute budget. Doing a full build on my machine right now, including WebKit and GStreamer and everything else, is about 18 minutes. Most of that's WebKit. And so we're still sort of fit into that. Now, if what you're trying to do is just contribute a patch, then you don't have to do a full build. You just have to run JavaDoc. And in that case, you could probably produce the JavaDocs in about 2 minutes. So anyway, so my goal is to make it easy enough that you can do that. One of the other challenges is that there's a bunch of prerequisites that you have to have installed on your system in order to build because of the native code. Native code's so annoying. And because we've got GStreamer and WebKit to build, if you build those, you have further prerequisites. For example, WebKit's based on Qt, and so you have to download and install Qt framework because they use QMake and other things like that in order to build. So there's a bunch of extra stuff that you have to download and install if you want to build literally everything. So one of my goals with the new build system was to make it so that you actually didn't have to download and install anything in order to build. As long as you had Java and Mercurial and Gradle, you'd be good to go. So you could clone the thing and then build it. And the build system would be smart enough to say, oh, you're missing Windows SDK, you're missing DirectX SDK, you're missing Qt, you're missing some of these other things. I'll just build the Java for you, or at least give you the option so that you could just say, just build the Java stuff. I don't want all the other natives. Just go grab whatever the latest native binaries are, use those, and then just build the Java and go. Because I figure for most of us, that's what we'll be doing, right? There'll be some folks who are implementing font support on Pango, but not very many, maybe 3 or 4. And you're going to have some folks who are porting to a new platform, like, say, iOS. Okay, maybe you'll get 20 or 30 of those people who are in there cranking away on that. But you're still talking a relatively small number of people. Most people who want to contribute a patch, your experience is, I've got this bug in UI controls. It's really bothering me. It's not scheduled for this release. So, I am so totally annoyed. So what I'm going to do is I'm going to clone this stupid blankety blank, and then I'm going to open it in my IDE, and I'm going to do a thing, and I'm going to hit run, and it's going to work, and then I'm going to create the patch and submit it and walk away. And then if I come back in 3 weeks and it's not done, I'll be really mad. But, you know, I will have gotten that experience. And that's what I want, is I want it to be that easy that somebody can just be really upset and fix something. Because I figure if you could do that, then that'll make you happy. So there's a bunch of things I'm looking at doing. One is to make it so that you can build the Java-only parts very easily. Another one is that the IDE support is really good for our new structure that we're working on, so that you actually can use an IDE. And another one is that something like Ensemble will be set up as the default run target in your IDE, so that when you've cloned and you've built and you got your IDE up, you can make a change, you can hit run, and it'll build everything, and it'll fire up Ensemble, and you can just see if it worked. And then, of course, the other parts of this are a wiki page that describes the thing, providing a patch in 3 minutes sort of wiki page or something like that just sort of takes you right through it, and then an easy way to make sure that everybody's aware of it. So those are all sort of little bits and pieces of the contribution process that we're working on to try to get it really easy and smooth so that people can not only contribute, but can contribute meaningful patches that will be easy for us to take and apply. So let me go ahead and start the slides for building and testing. So there's basically, leftovers is really short. There's basically three main sections. One is workspace reorganization, building with Gradle, using the IDE, and then just some leftover topics. Okay, so we'll start with workspace reorganization. Right now, in our workspace, we have far too many projects. It's kind of like when I go to WebKit sources and I'm looking around trying to figure out where the heck I'm supposed to find something. It's pretty difficult to find it in the mess of things. And for us, it's really bad. We have many different little micro projects. There's about 90 of them overall. And it's a pain to maintain all these things in the build. And we sometimes do weird things in the code as a result of all these micro projects. So for example, legitimately, for any version of JavaFX that's going to run, it has to have Glass, the windowing stuff, Prism, the drawing stuff, and the scene graph. It's got to have those three things or you're not going to get any bits on the screen. But for some reason, and I know the reason because it was my fault, but for some reason we've got that split out into multiple independent little projects. And because they're multiple projects and in your build system you can't have circular dependencies, we have some one-way dependencies that are actually two-way dependencies, but we had to turn them into one-way dependencies for the sake of the build system, which meant that you had to use reflection or some other sort of hack in order to get it to build the right way. Or maybe sometimes you have some unit tests that want to use the bits that's in a different project, but it's a circular dependency, and so you have to set it up so that the unit tests run after the other things are built, and the build's just a mess, right? So this happened over time. It sounded like a great idea to have these little mini modules when we started, but it turns out it's a pain in the neck. So in the new structure, we have about 12 module projects. So we've taken these things and collapsed them down to the actual functional units. It's like I say, you can't run Prism and Glass without scene graph and vice versa. All those things have to be together anyway, so let's turn them into one module. And once they're one module, you can do all kinds of good stuff. Another problem that we have is we have way too many repos. Now, you don't really see this in the open source because on the open source side, we've been fixing it as we've gone along. We used to have something on the order of 7 or 8 repos. There was an apps repo. Well, there's the root, apps, media, web, RT closed, tests. I think there's a couple more. So it's at least 7 different repos in a forest. And Mercurial actually isn't very good at dealing with forests. It wasn't ever designed for it. Forest was an extension, but it's not built into it. So, a lot of the different Mercurial tools like Bisect just simply don't work because you've got code spread over multiple repos in a forest. Just doesn't work. Coordinating pushes and pulls can go wrong. You push, you've got a fix that spans multiple repos. You push to multiple ones, but darn it, Hudson kicked off when only got half of your pushes and not the other half. It happens periodically. It's just annoying. It's not that big of a deal, but it is annoying. And then third-party tools like SourceTree or Crucible, et cetera, don't understand it. It just views each repo as its own world, and it gets confused by these things. So our goal is to just have one open repo. That's it. And that's what we're doing. So web, media, the SQE tests, all that stuff is going to get folded into RT. For the next, when we open our next repo, so right now we've got the Java 8 repo there. When we open 8.1 or whatever the next one is, there's not going to be a root and an RT. There's just going to be the JavaFX repo, the end. One repo has everything in it. So our current project directory, if you're looking in the root project here, it's got all this, there's just a lot of stuff.
So let me fill you in on a little chat going on the stream, but the usual question about, JIT versus Mercurial came up.
Oh, yeah.
So feel free to address that along the way.
Well, I mean, it's out of my hands. We use Mercurial. That's, I don't know what to tell you. It's, yeah. JDK uses Mercurial, so we use Mercurial. So the current project directory has a bunch of stuff. The new one has less stuff. It's actually even less than that now. It's just consolidation and cleanup is basically it. Chaos is a natural state of affairs, right? What is the second law of thermodynamics or something, right? It's just normal. So you got to fight it all the time, and right now is the time for us to fight it because it just got way out of hand. So these are our base modules that we have, our core set of modules. There's 11 of them. I put 12 in the slide because it's likely that we'll come up with a few more as we go along here, but this is sort of the subset. So there's a base module, which actually contains a subset of JavaFX that's useful outside of graphical applications. So this is like the properties and binding stuff. So if you wanted to use that on the server side, you could just grab the base module and go, and it won't try to fire up, any of the graphics stuff. You got the graphics module, which is the other stuff. Scene graph, glass, prism, all the things you need to put bits on the scene, on the screen. UI controls, swing, so all the swing interoperability stuff is in a module. SWT is in interoperability is in a module. FXML, which is the XML-based markup language, lives in its own module. Excuse me. Then media, web, design time doesn't actually show up in the external world yet, but it's sort of a, we're working on some design time APIs that are used by Scene Builder such that when this API is done, it will be available in the JDK and people would be able to write third-party controls, use these APIs, bundle that all together into some kind of a jar or artifact, hand it to Scene Builder, and Scene Builder will be able to understand what you're supposed to do with your custom panel or your custom control.
You can see live views in your IDE.
Yeah, exactly, and see the live views, and in the property sheet, it'll get you the right stuff. There was, Java Beans that Swing used had some basics of this stuff. We were at the time working on a replacement for it called the JSR 273, I think, Design Time API for Java Beans, and it was way more comprehensive. This is based on that work, so it's way more comprehensive than what we had before. So our goal is actually that Scene Builder have no internal knowledge of JavaFX, that it just talk through these interfaces for everything it needs to know. If we succeed in that, we figure that any third-party control will fit naturally and natively right into the Scene Builder. It's not there yet, but that's why it's not a public API yet, because we're still feeling that out, trying to figure out what the right way is to do that. FX Packager is the tool that ships with JDK that's used for either creating a JNLP or applet or co-bundled application with native installers and all that sort of stuff. So that project lives there. And then JMX, which is just some JMX mbeans that are used for monitoring and management of your application. So you actually can use some tools to inspect a running JavaFX application and find out how many times it was synchronizing and what the FPS is and all that sort of stuff.
Okay, so there's another question going on the thread about artifact management using something like Maven or BinTray and inclusion in the JDK as a first-class bootstrap class path item.
Say that again.
Right now in Java 7, you have to add the jfxrt.jar to your class path because it's not
In
included
7,
on the
yeah.
Bootstrap.
In 8, it's on the.
Yeah, that's what I wanted you to.
Oh, that's what you want me to say. Yeah. So in any of the later 8 builds, it's automatically part of the class path. So, which is great if you're a user, but it's lame if you're a developer because if you're developing JavaFX itself, because the darn thing shows on the class path before whatever the hack is that you've been working on. So you have to do some finagling to make it to work. But I'm going to handle all that for you so that my 30-minute patch thing actually ends up working. So anyway, this is just some simplification, who cares? So for example, these 5 micro projects make up the base module. It's the beans stuff that we created, the converters, the actually the animation does not really belong here. It's going to go to the other one. Right now, anim was split into 2 parts, but we're going to be getting that stuff out of here and put it into the other one. JavaFX common and JavaFX login. So those things go there. In the graphics module, this is where you see a lot of the little micro projects disappear. Just all these things get rolled up into one module. Makes it a little easier to manage. So this is, right now, like I was saying, we're building with Ant. Now, my goal with the new Gradle build and test was to do 2 things. One was to switch off of Ant, and the other one was to create this wonderful new structure with fewer projects and make it wonderful for everybody. Well, obviously we couldn't stop the whole world from stop all of our guys from developing while we did that. So what we have is there's this generator Gradle script that you run that will copy all the stuff from the RT directory into a sibling called JavaFX, and then it will have all the sources in all their new places the way that it will be when we flip the switch and go to the new structure. So what you need to do is you got to get inside the RT directory, run this Gradle script, and it generates a new world for you. That's all. It takes about, 4 to 10 seconds. It's pretty short. Once you've got that new world, you'll see the following. One is there's a top-level directory that's called apps. And inside apps is where we put things like Ensemble, the conference scheduler, Brick Breaker, and all the other samples, demos, and so forth that we write goes into apps. The build directory is auto-generated during the build process, and it's got all the built SDK, Java docs, reports, and all the other sort of stuff. Currently, we create a directory called artifacts, but since we went to Gradle, and Gradle by default creates a thing called build, we just said, okay, we'll just adopt the new convention and call it build. That makes sense. This actually is an old slide. It's not called build tools anymore. It's called build source. Gradle has a special build source, and everything that was in here is now in build source. So build source has like annotations, the builder processor that we use to auto-generate all of our builders, and any other tools that are used at build time but are not part of the final SDK. Those things went into build source. Functional tests. This directory doesn't exist yet, but it will when I take the SQE tests out of their repo and stick it in this one. So we'll have a directory called functional tests, and it will have all of the tests that are intended to test the entire system together. So this isn't like unit tests, but it could be GUI or non-GUI tests. And it could be automated or manual tests. We'll have all those things sitting in functional tests. So this is another thing that's not been the case with JDK development. It is going to be the case with JavaFX development, which is the tests that we use will be available to you so that you can develop on an equal footing with us. Because I think that's sort of important. Otherwise, how are we going to get good patches from people? People will give us a patch. We'll run it on our tests. We'll say it fails tests. We'll give it back to you. You'll be mad. You'll change it. You'll give it back to me. We'll run our tests. And we'll say, oh, it was too slow. We'll give it back to you. You'll be really mad. I mean, it's just not a good system. So we're just going to make everything available to you and make it easy to use. It takes a lot of effort to do that, incidentally. I don't know how it is at the places that you guys work, but certainly for us, it's always been like, well, the build system is just sort of working, right? We sort of play with it a bit to keep it going, and then eventually gets kind of out of control. I think that's
or it's not working.
Or it's not working. Yeah, I think that's sort of the normal state of affairs. But when you're trying to do an open source project and get people to actually contribute, it's not good enough. You got to treat it like a product, make it really nice and easy to use. The upside is if you put that sort of love into it, it'll make the developers that we're paying more productive. That's
Okay, so two questions on the stream. So one of the guys is wondering what the advantage of is Gradle over Maven. And the second question is the performance difference between the Gradle build and the previous Ant build.
Good questions. So I'll answer the question on Maven in a few slides. So we'll get to that in a second. The performance difference is okay. So actually, let me get to both questions in just a bit. I'm going to talk about the structure, and then I'll get to Gradle. And in Gradle, I will give you the good and the bad. I've been using the thing for, I don't know, 3 months now, I think. So I'm starting to become quite familiar with it, and so I can give an honest assessment, I think, of where it's at. So modules directory contains all the modules that we looked at on the previous slide. They're all in that little guy. And then there's various IDE files that are generated by Gradle on demand. So if you're using IDEA, you can generate IDEA project files. If you're using NetBeans, you can generate those. And if you're using Eclipse, you can generate those as soon as somebody contributes support for Eclipse. And then inside each one of our modules, we just follow the normal industry standard naming conventions that Maven has popularized. These are different than anything we've ever done before in the Java group, but I figured, well, actually, I did have a different naming convention at first, and then the guys on the mailing list said, "Oh, you fool, just stick with the standard." And I was like, "Oh, I hate the standard. It's like 18 levels of nesting." And they said, "Just do it." So I said, "Okay." So I did it, and within like 3 hours, I was used to it. So I figured that's what we'll do. We'll just stick as much as possible to just stock and standard conventions, not make up anything new. It'll save us down the road. So, for many people who are using Maven or Gradle, you'll be able to come to this and find your way around pretty easily, I think. We don't care about that. So, I was originally presenting these slides to the internal team, and since none of us have ever done this before, it was, I had to put in some extra disclaimer about how I had structured things. And to be honest, I don't know if I did it exactly right. So if anybody knows this stuff better, feel free to come on the mailing list and abuse me. But, so you got source main Java. That's great. And then occasionally there's some other guy who's sitting in there like this version info. What the heck is version info? Well, in our build, there's this class called version info. And it's got tokens inside of it. And during the build process, we take it, we copy it to a different location, we replace the tokens with information we get from Hudson, such as what the build number is and so on and so forth. And then we compile that thing in its new location, and then we take its class file and bundle it into the universe and so forth. And so any time that it was just not a straightforward, here's your Java sources we compile and stick in the jar, I broke those out into another directory so that we knew that it was handled specially. And then native. We have a ton of native code. Actually, the vast majority of the native code is WebKit and GStreamer. The other native code that we have, there's enough of it, but it's not daunting. It's fairly reasonable. But we do have native code, certainly more than most Java projects. So for these, what I did was I created a directory under source main called native, or source main native dash, and then some indication of what it's got the natives for. As you know, native sources don't have to be structured in anything like Java packages. There's no strict structuring convention. At present, our code is sort of structured ad hoc, the native stuff. I would like to do a pass later and standardize the way that all the native things are structured so that I could simplify the build a bit. But anyway, it's not that bad. So for example, all the native Decora stuff that does all the native, if it's using software native loops to do the effects, that code is right here, the SSE, box blur, etc. Native glass, GTK, iOS, Lens, Mac, Windows, all those things are there. So if you're hacking on iOS, the sources are all there. It's all open source. You can just go in and see what those things are. Native Prism, Prism software pipeline, all that sort of stuff is all just right there. There's a lot more now too, such as the D3D stuff has been open sourced and some of the ES2. So there's a reasonable amount of native code, but it's all contained in little native folders. So it should be pretty self-explanatory when you get in there. So now that the scene graph and Prism and Glass and these guys are all in the same module, they can all see each other. One of the next steps is to go in and remove all the useless abstractions that we had put in there. They actually weren't useless abstractions. We had abstractions in there for purposes other than satisfying the build. But none of those abstractions are really that necessary anymore. So there's a lot of things that we can do in order to simplify that code base, make it smaller, make it faster, easier to understand. So that's one of the things that we'll be doing once we've got to this new structure. So for example, right now, the way that it works is that the scene graph talks to what we call the toolkit through a set of interfaces. And then the toolkit talks to Glass. And so when an event comes into the system, Glass takes that native event, turns it into a Java object, passes the Java object up to the Quantum toolkit. The Quantum toolkit takes that Java object, turns it into a scene graph event, and then posts it to the scene graph. It's like, why do we have the extra conversion of the event? Why didn't we just go from native directly to Java object that we passed to the scene graph? Well, the reason is because the build was separated from each other and Glass didn't know anything about the scene graph, so Glass couldn't do it. It had to create an intermediate thing, and anyway, it's all awful. So now that we've fixed those things, we're going to be able to clean all that sort of stuff up. So that's good. Okay, now, building with Gradle. So here's the question here's the answer to the question, why Gradle, not Maven? Okay. I think this is very accurate. This comes from their website. I think this is very accurate. I don't think that there's any marketing speak in here. This is my experience. Gradle combines the power and flexibility of Ant with the dependency management and conventions of Maven into a more effective way to build. Powered by a groovy DSL and packed with innovation. Okay, packed with innovation is a bit much. Okay, but I mean, there is a lot of innovation in there, but it just, packed with it. It's this marketing speak. Gradle provides a declarative way to describe all kinds of builds through sensible defaults. I think that's an absolutely true statement. Maven is fine when you're not doing anything weird, but we do a lot of weird stuff in the build of necessity. And I mean, it's mind-blowing when you go. This is why it's taken me 3 months to get to the point that I'm at with the build system. There's so many little niggles. We build for 7 platforms at present, 9 in the near future. We build for Linux 32, Linux 64, Mac 64, Windows 32, Windows 64, ARM hard float, ARM soft float, both version 6, incidentally, and iOS and Android. Although we don't ship either of those, they're just in the open source stuff. So I haven't got those in the Gradle yet, but soon I will. And then that gives us 9 things that we build for. Heaven forbid we should start building for ARM version 8 or something else, right? There's a lot of different platforms. And because we have native code, it's not as easy as just doing a single compile and having a jar and sending it out there. We have native code, and the native code has different command line switches depending on which platform you're building on, whether it's Linux, Mac, or Windows, completely different command line switches. It's got, different libraries that it's linking against. When you're building on the ARM soft float versus hard float, you need completely different tool chains to compile with. You can't compile with the normal GCC. You got to be using a special tool chain that knows how to compile for either the hard float or soft float, binary interfaces and so forth. There's a lot of this sort of stuff that has to be taken care of. Obviously, how we package the whole thing up is going to be unique because we're producing a package structure at the end of the day that matches what the JDK produces. So for example, where does a DLL go? Oh, well, of course, it's the DLL, an SO, or a dylib, depending on what platform you're on. And where do those things go? Well, it depends. It either goes in the JRE/bin directory if it's on Windows, or JRE/lib if it's on Mac, or JRE/lib/ARM if you're on one of the ARM platforms, or JRE/lib/i386 if you're on 32-bit Windows or Linux, and AMD 64 if it's the other. Yeah, I think those are the only combinations. But it's weird. There's a lot of weird stuff going on.
Okay, so Eric had a question on the stream. He's wondering why you couldn't do those with Maven Mojos. And I think he's more familiar with Maven, so he's not criticizing Gradle. He just doesn't know that much about it.
Yeah, I'm not familiar enough with Maven to know. I relied on a lot of advice from people I met at conferences. This is what I've heard. Yeah, is that you can, but so I don't know. I don't know. Like even like the version info guy, I don't know how you handle those sort of odd cases. So anyway, it's just a big nasty. And this was actually the main problem with Ant, was that Ant does not give you. Okay, so obviously Ant doesn't have dependency management, although you could use Ivy to achieve that. So it would be possible to have redone the build system in Ant and Ivy. But I hate XML, so just do it. The other thing is that Ant, it's got that, what I call the declarative straitjacket. I mean, you just can't do something procedural if it just makes more sense. You just can't do it. Unless you're going to go write some Java code, create a plugin, stick it into the whole Ant system and so forth. It's just more painful. So that's why I picked the Gradle. So some of the other pluses aside from that, the command line interface is really great. I really like it. The IDE support is really good. Like I say, there's no declarative straitjacket, which is a pro and a con, because somebody who's working on the build system could just go crazy and write a bunch of procedural stuff and do it all the wrong way, if you will, and it makes it harder to maintain. But if you do it right, it's really powerful when you need it. It's got the dependency management built in, same as Maven, and it does a good job on the incremental compilation. The only real problem with Gradle is that there is definitely a learning curve involved. And partly that's Gradle, but to a large extent that's Groovy. I run into Groovy problems every day that I'm just looking at the code saying, what the heck is wrong? Why doesn't this work? I had one today. I was missing a comma. Nothing told me I was missing a comma. I got, blah, 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 closure, blah, 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 doesn't accept arguments, blah, 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 blah. I mean, the names of these closures that were auto-generated by Groovy were like this long. I mean, you're looking at it and you say, what the heck did I do wrong, right? You go look at the line of code and you're staring at it and you're like, I don't know. And so then I started giving parameters to these closure arguments, and the error changed. It stopped telling me that line was bad, and it was telling me a different line was bad, and I went and fixed that one, and then it gave me some other error. And it turned out all that was really wrong was I was missing a comma between two closures passed to a method. I have no idea what it was doing, but it was a pain in the neck. Okay, so Groovy is causing me pain. It is just, it's just the way, that's been my experience. A lot of things that it does are kind of nice until you start hitting edge cases where it's like, so for example, they've got these, what they call the G strings, right? You can pass in $, name of the variable, or $, brace, variable, close brace. And so sometimes I wouldn't use the braces because it was nicer without it, right? That's the whole point of Groovy, is that you can do things in sort of a nice little way. It's dynamic language or whatever. But it had unexpected side effects from time to time that I was just didn't anticipate. Throw the braces in, all of a sudden it was working. It's like, okay. I don't really understand what's going on there. Also, the fact that when you use those G strings, then sometimes, like for example, there was a method, and the method takes objects, and it was like map, right? You're doing a map dot has property or something like that. Map dot contains key, and the keys were strings, but it turns out I wasn't passing it a string. So I always think of it as these little G strings inside the string thing is actually a string. It's just syntactic sugar for adding a string and passing it in. But this is not the case. It's a G string object. And so it was checking this hash map to see if the G string object was a key. And it wasn't. They were all strings that were keys. And that was just messing me up. You go back to, quotes with pluses and life is good. So there are things like this that are just going to impact you. If you don't know Groovy, if you don't know Groovy, you're going to have a little bit of pain. Use a Gradle. Not to mention just trying to understand the syntax for the first time. Took a few weeks. However, on the other hand, I took out the previous slide. We had somewhere on the order of 30,000 lines of Ant in our build script. And that's not counting any of the samples or apps or any of that, or tests. Okay, that's just our build system. Okay? Yeah, wow. Now, a lot of that was boilerplate nonsense that we were repeating over and over and over again because we had a zillion little micro projects. But it was it still is. It's very hard to understand our existing build system. I've been doing this for like 3 months straight now, and I've gone crazy. It's very hard. Our new thing is like, 3,000 lines of code, so it's much more manageable. It's still borderline, I mean, it's still complicated. But that's because our build is complicated. So the nice thing is that right now, if you go read the Gradle stuff, it will tell you what our build is doing. And where it's complicated is because our build is doing complicated things, where it's, like the whole version info. Take the thing, replace the symbols, copy it to the generated sources, compile the thing, create the classes, include these classes. When we're creating an SDK that's going to run on Mac, make sure that you include these packages, but exclude those packages. And when you're building on, so those sort of things, they sort of come out at you, because that's pretty much all that's in there. Because Gradle's got good conventions, and we follow the conventions by default, pretty much all you're looking at are all the exceptions to the rules. So there's like 3,000 exceptions to the rules. I'm just saying, it's a complicated build. But that does also include all the build logic that I added to generate the IntelliJ and NetBeans project files, which is significant as well. So it's not all bad. So here's an example of the command line if you haven't used Gradle before. It's just this nice, I just was like, oh, look at this, nice little touch. They got the colors on there. But one of the things that you can do is you can go to any Gradle project and just type in Gradle Projects, and it'll show you all the different projects that are involved in this project. So in our case, our root project is JavaFX, and then there's a project for each one of the different modules, for example. So, it's convenient. It's got the colored output, which is really nice. There's a way to turn that on for Ant, but with Gradle, you sort of just get it for free. Camel case task lookup. So if you want to run a task, you can just put in the camel case letters, and it'll find the right task and run it. You don't have to type in the whole thing. A task in Gradle is like a target in Ant. It spits, by default, when you do a build, it spits out the minimal stuff, whereas like our Ant thing is just like spews at you. You can never find what you want. You can run Gradle Tasks, and it'll tell you the most useful tasks that you can execute. Gradle Projects shows you all the projects, that sort of stuff. So it's just really convenient. When you run the tests, instead of things just going woo, zipping by you, it just has this little guy on the bottom that says, here's the project, controls. I'm running the test target on it, or task. And so far I've run 4,606 tests. 150 of them have been skipped. And it would tell you how many were errors or whatever. And it just sits there and counts them up, and then when it gets to the end, it goes to the next thing. So again, it's just kind of nice by default, instead of having all that text go spew. Now, of course, you can spew all day long. You just have to pass it some parameters, and it'll start putting out all kinds of extra crap. But by default, it just kind of keeps it nice and tidy. So tasks are, like I say, kind of like targets. These are the things that you do. You can have one task depend on another task. So for example, jar depends on classes. Same thing as an Ant or anything else. Tasks can be run in parallel. Gradle has support for running these things all in parallel. However, ours doesn't do that yet. It's one of my goals to get to that point. So we want to, and it's not just for your machine, although that's part of it, is to saturate your CPU when you're building. So that it takes less time to build. But it's also for our whole, Hudson infrastructure and all these things. Right now, it takes about an hour to hour and a half to build the full JavaFX on Windows i586 on Hudson. I don't think that includes the unit tests. Pretty long. And running the unit tests is like, 20 minutes or 30 minutes, something like that. So it's kind of problematic because Hudson doesn't get back to you very quickly. What we're trying to do is to fit the entire build and test into about 30 minutes. Now, I could do it in a lot less except for WebKit, which is hopeless. So we're trying to get it to that point. If we can get it to that point, what that means is that as a developer working on the project, you'd be able to do whatever you're doing, and when you're getting ready to push, you'd be able to just go do a whole clean and build. It'll do a whole clean and build on, so the way that we're going to do it is you work on some stuff, you do some local testing, you say, yes, this is good. You push it up to a machine, which is then going, it's a whole farm, and it'll take your patches, it'll do continuous integration. It'll take the latest head, it'll merge it in, it'll build and test on every single platform that we support. If it passes that first set of tests, then those binaries will be pushed to the continuous integration side to say these are the latest continuous bits, and then it will take off going through a whole pipeline of more rigorous tests that ends up lasting 3 or 4 weeks overall. But progressively more complicated tests as it goes. And part of that pipeline, it goes through nightly tests and produces nightly artifacts, and weekly tests, which produce the promoted artifacts, and then more extensive longevity testing, which is just used to find bugs and stuff like that. So it's important for us to get our build and test cycle really, really short so that we can make this an automated process. Because you can imagine if you have, you know, dozens of engineers working on this thing, and I can't give you numbers, but it's lots of engineers working on this stuff, and it takes an hour and a half to do a full build for each person, you're not going to get real continuous integration because everybody will be colliding with each other and it'll never work. So that's what we're trying to get to. Okay, basic tasks that are available to you by convention. Clean, hello, yeah, who would have guessed. Assemble, which basically creates the project deliverables. Build does the assembly and the testing. Classes compiles, jar produces jar, tests, so forth. So each one of our little projects has their own set of unit tests. That's what's run when you call Gradle test. Now we'll have other Gradle test tasks, eventually. For example, I want to run all the functional automatic tests, or I want to run the pre-commit tests, or whatever. It'll just be something like Gradle pre-commit tests, and it'll run the functional tests. It'll do all the build, and then run the functional tests that are required before you could do an integration, that sort of stuff. So our entire build system, everything from what we would do as a developer to what they do in release engineering before the bits are finally put out onto the website, all that stuff is going to be inside the build system and available to anybody. The difference is, of course, the real bits that we put out in the web will have digital signing and everything else from Oracle certificate. Obviously, that's not going to be included. So that'd be bad. But anyway, so anybody would be able to produce a build. And this is really important from the OpenJFX and OpenJDK side, right? You want to be able to produce an OpenJFX build on your own local system. And it should be exactly the same as what we would produce if we were doing it. And that's what we're doing, to get all that stuff built into there. Oh, Gradle clean, whatever. Gradle SDK, oh boy. Creates an SDK based on the platform you're running on. -I or --info gives you more information. Q hides more stuff. Debug or -d will show a heck of a lot more stuff, which is mostly not necessary unless you're debugging the build itself. This is a simple way to just say, I want to clean only the graphics module. So there's a convention :separated in Gradle. So, you know, graphics is the name of the module, : and then the task that you want to execute. This one will build all the native stuff for the graphics. Okay, generates the JNI headers, does the compiling, does the linking, the whole 9 yards.
A question about a statement you just made about the certificates.
Yeah.
They're saying is he's saying OpenJDK is not signed. Of course, that's not.
Right. Yeah, I'm saying the Oracle JDK ones. Yeah, because
Distribute your certificate.
no, those won't be available to those won't be available to hardly anybody inside Oracle. It's like, you know, 2 people or something like that have that. But yeah, OpenJDK has no signing. It's just OpenJDK. So, okay, how do you deal with different properties? Okay, Gradle has a Gradle.properties file, and it's part of our build system. You see it right there. And everything in it's commented out. It's one of those where you look at it, you figure out which things you wanted to change, copy the thing into your home directory. If it goes into your home directory, .gradle/Gradle.properties, it takes precedence over what's inside the JavaFX Gradle.properties file. So typically what you do is you take JavaFX/Gradle.properties, copy it over into home directory.gradle, and then go uncomment the things that you wanted to modify in terms of what's special about your setup. And of course, you also can pass properties with the -p flag, and there's a bunch of other ways to pass properties in Gradle. You can do it with -d flags, you can do it with environment variables, there's a bunch of different ways that you can set it up. But the point is that we have exposed a bunch of properties that you can set in order to change how the thing builds, and the most convenient way to do that is to just stick it in Gradle.properties, in which case we'll just pick it up and run with it. So here's an example. If This doesn't work today. Like I said, the Android and iOS builds in Gradle aren't set up yet. But if you wanted to build something like Android, what you'd do is you'd say Gradle -p compile targets equals Android SDK. And what this does is it just says, you know, what is the SDK you're trying to create? Oh, it's the Android SDK. Okay, that's what I'll do. So this is one way to do it, to pass it as a -p property. The other way to do it is to, like I say, put it in your Gradle.properties, and then you don't have to pass the -p. You can just say Gradle SDK, and it'll do the right thing for you. So there's a whole bunch of documentation in the thing that tells what each one of the properties are, you know, proper syntax and so forth. So it should be pretty straightforward how to do that. One of the other things Gradle does nicer than Ant out of the box is the reports that it produces. So there's a bunch of ones that it produces for free, such as JUnit test reports, and also a build profile that can tell you where you're spending all your time in the build itself. There's also, in the newer versions of Gradle, a way to produce some sort of project dashboard that has all sorts of information from all the different sub-projects. I haven't tried it out yet. So here's an example of the little web page for the test summary. You know, it's just nice. The profile report, here's an example of that. And so I'm looking at the task execution time itself, and you can see that the entire project took 13 minutes, and of that, 11 minutes and 10 seconds was compiling WebKit. Yes, WebKit takes forever. So there's a bunch more stuff here on sort of, I guess, Groovy and how Gradle works, but I don't know that it's really worth us to go through that unless you guys were really interested in it. But there's a few things that are kind of useful, I think. Whatever. I don't care about this stupid G-strings. They're both wonderful and frightening at the same time. I mean, I use them all over the place, and I want them to be so awesome, but darn it, it's not a string at the end of the day. It's a G-string object. You got to remember that. It's a little hidden thing there meant to trip you up, I think. Another one is dynamic properties, right? So it's a dynamic language, so you can assign arbitrary properties to arbitrary objects. Gradle will warn you if you try to do that. But there's this magic map called ext that lives on the project object, and as it turns out, on a lot of other stuff. And this one really caught me too. So it's really annoying. But anyway, so there's this principle that Brian Getz was trying to live with when doing lambdas for Java. And it was basically, you should be able to take a chunk of code, stick it inside a lambda, and it should mean exactly the same thing before and after. That's not the case with Groovy. You take code that was outside of a lambda, and then you stick it inside of a lambda, and it could end up doing something completely different than what it did before. So for example, you take this code that says ext.is64, you stick it inside of a lambda, and it is going to try to assign that is64 property to a lambda created, you know, some Groovy created object associated with that lambda, as opposed to the project object, which it should have captured and been assigned to. I'm just drive me crazy. You love it, but sometimes it bites you. It's like a, I don't know, a gator for a pet or something. I don't know. Anyway, but you know, there's a lot of great things about it. It's a lot, like I say, for me, it's a lot nicer than a bunch of XML. And there are some things that are just really powerful. Like you can use enums in the thing. You know, it's just because it's a programming language, you can do a lot of really cool stuff. We don't care about that. We don't care about that stuff. This is all just basically syntax, how to map the syntax, but I don't think that's worth us spending too much time on. Here's an example of one of the Groovy closures. I love them. It's great. I can't wait until we've got this stuff. I mean, it's in the Java 8 builds, but to be able to actually program with closures, I think it's going to be really, really great advancement over what we've been doing. None of these are good examples, though, of writing a bunch of code. Yeah, none of those are good examples. So there are some good places, though, where it's like, well, this one's not bad. So basically what this one does is it says for each JSL file that you find, you're going to create a new task that says compile this JSL file. So for example, our JSL files, these are Java shader language. It's sort of a non-public shader language that we use internally. And what it is it's a shader language that tells us how to do all the decor effects. Now from it, we generate D3D shaders, OpenGL shaders, SSE code, and Java code, so that we don't have to write that 4 different times. We just do it the one time and generate it. So we have a bunch of these JSL files, and so what this code does is it takes each JSL file, creates a task for it. And doing this sort of thing in Gradle and Groovy, so easy and powerful. Doing this in XML is not. So that's one of the things I really, really liked about it. So IDE support. You can ask Gradle to generate a project file of your choice. You just type in Gradle space idea. It'll create the idea project files. And the idea project files that it's generating have all of our defaults in it. It's got the right copyright header for OpenJDK files. It's got, you know, spaces instead of tabs and all that sort of stuff set up. So that when you open the project file up, you should be able to just start whacking away, create a diff, send it to us, and everything will be in the right way. Haven't done it yet for Eclipse, and the NetBeans one is half there. NetBeans is actually a different beast. I'll get to it in a second. It's really nice. Don't care about that one. So we don't care about that. So here's an example of what it looks like inside IDEA. You know, there's the apps directory that I showed you before, build tools, which is now build source, functional tests is sitting there, modules with all the different modules underneath it, all the different, you know, source directories, test directories, everything else. It's just a perfect little IDEA project, set up and ready to roll. NetBeans is really nice in that NetBeans has a plugin that understands Gradle natively. Gradle has a tools API with it that NetBeans can just use. And so that's really nice. You basically don't have to do much. In fact, the only reason that you would say Gradle NetBeans in order to generate a NetBeans project file is just to create those defaults, such as the project, you know, the templates for new files and things like that. Otherwise, you wouldn't even need to do that. You just open it up and off you go. But it's really nice. I was really pleased with it. Not only that, but the folks who maintain it are super responsive. I mean, you know, they're sending me more email than I could handle. I was trying to keep up with them and say, yes, this feature, no, not that one. So very, very responsive. So it was really nice experience actually to use NetBeans for that, which I wasn't expecting. So it was really great. Some simple leftovers. Like I said, I haven't finished the Android and iOS builds. I haven't finished the bundles. So when you do a build, it'll give you SDKs, but it doesn't produce the zips and the tar GZs and the other sort of stuff that would show up on the website. None of the closed tests run. It's just the open ones that run at the moment. I haven't done the Eclipse project generation. And I haven't, although I've generated it and opened it up in an IDE, I haven't really whacked on it yet. You know, I haven't tried to fix bugs in the new world structure. So, but it should be okay. So that's basically what I haven't done yet. Some future stuff that needs to be done is to simplify the build. So once we've gone over to the new structure, there's a lot of things that we could do in order to be more consistent. Like, for example, how the native code is all structured or built, or what our native flags are that we use. Because right now, our native flags, there's at least 4 different, there were at least 4 different authors involved in writing the make files that we're using in our existing build script. Because you can tell, because they're, you know, of the 25 or 50 different make files that we have, whatever it is, they're all copy and pasted from one of these 4 original ones. Because so you can sort of trace the heritage of where the thing came from by how it was written. And anyway, by just sort of breaking these things down and creating more consistent structure in how things are done, we could simplify some of the build further than what we've done. But like, you know, you're left looking at these make files and you say, why are the parameters that I'm passing to this to GCC here different from here? Is there a reason why there are different parameters, or is it happenstance? And it depends. Some of the differences are happenstance. I don't know. Somebody decided they were going to build with these warnings turned off and these turned on, and some people said they were going to use fast math and some didn't. And in other places, it made a big difference. This guy actually really should not have fast math turned on. If you do, you'll get rendering artifacts. Well, you just don't really know. So there's going to be some effort to do some, you know, trial and error to figure out which native flags we actually need. Anyway, and then find bugs, parfait, check style. There's a bunch of other things that we want to integrate into the build so that we get more consistent and clean output at the end of the day. So that's actually an area that I think will be fertile for doing, for contributing. Is, for example, the London Jug has been very successful on OpenJDK doing fix a warning days and things like that. They'll set up a day, they just get a bunch of people together, and they'll just hack on the JDK as a group, just for fun. So instead of me up here jabbering, we just show up and say, yeah, let's fix some warnings, right? And so you'd run the build, and you'd find some warnings, and you'd go fix them, and you'd submit a patch, and then over the course of the next week, the engineers at Oracle will be going through those things and applying them and getting those warnings under control. So find bugs is a perfect example of that, right? Find bugs is going to generate a ton of noise. And some of it's good, and some of it's just going to be noise. But it's going to take some effort to go through all those things. So we're not going to just turn find bugs on overnight. We'll probably go module at a time. We'll say, well, let's go to the base module. Let's run find bugs. Let's get rid of all the build warnings. Let's get rid of all the find bugs warnings. Let's get it all cleaned up. And I think those are great. Those are the sort of things you ought to be able to do that sort of thing in a hour's time period. So those are really good opportunities to sort of get your feet wet. And once you've got your feet wet and you know how the build system works and the contribution and people are on the Oracle side, know who you are and they're used to you, then you can start contributing all sorts of other stuff and it'll be a lot easier. So for example, Tom Schindel contributed a bunch of fixes to controls. And we know Tom, and he has been contributing for a reasonable length of time. So it was a lot easier to get his patches in through the queue because we sort of know what to expect from him.
So if we organized a JavaFX, OpenJFX hack day here, who would be interested in actually participating? Anyone? Maybe? All right. So
well, you sat through the whole thing. You got to fix a bug, right?
we at least have a few folks who are interested here. So yeah.
Yeah, and that's it. That's all I got.
There was a question when you were running through the IDEs about Eclipse, of course.
Yeah.
You mentioned it earlier.
Yeah, I just didn't get to it. So I figured that there were enough Eclipse users that somebody would contribute it.
Yeah.
So that's what I did. That's right. Somebody will do it.
When you do your native code compiles, are you using cross compilers, or are you running them, like I do, you running it on an ARM box to compile the ARM code?
Yeah, no, we do. It's cross compiles. So there's a, I don't know if it's open yet. I don't know if it's on the Open Wiki. But there's a, yeah, I'm not sure. Anyway, there's a good wiki that we need to get open if it's not out there yet, which has exactly which tools need to get downloaded and installed in order to build. So I've got, I don't know, somewhere in one of these, one of my many things, it's got them in there. So each platform uses different tools, obviously. We use a Microsoft compiler, so you have to use Visual Studio 8 or 10. How do they, it's 2010. That's what it is, 2010. So that's the Visual Studio. It's GCC, obviously on Linux. Oh gosh. Hate it when stuff gets lost in the, there we go. So, I mean, look at the name of that thing. This is, whatever that thing is, that's what we're using for building for hard float. Soft float is this guy here. And this one's hard float as well. So anyway, the compilers are in one of those, and some of the libraries and stuff to compile against are in the other. But yeah, so we use the cross compile there. In fact, there's no reason why you shouldn't be able to build OpenJFX on ARM, but I don't presently support it. I know that there was some problem somewhere. Our embedded guys were trying it out once, and they ran into some problem besides the fact that it just took forever. Yeah, forever. It's actually very fast on desktop. It just pops them all right out.
Any other questions for Rich?
Well, you are.
We're also asking online.
Say again?
We're asking online to see if there's any questions as well. So
Yeah. No.
they
You guys are all brave souls for either that or really bored.
No, I think they've been asking the questions as we went along. We
Okay.
didn't hold back
That's
along the
good.
way. So
It's been a lot of work to try to get the build system under control, but that's what we're doing it for, is for people, so that when you get really mad at something, you can come flying in and fix it. And that's I mean, I know it's really hard to get into a new project and be able to hack on it, and a big part of that is just getting started. Once you get the build environment set up and running, and you can make a change and run, see the thing work, I mean, you're 90% of the way there. The fixes are pretty easy after that.
all right, cool. Well, I want to thank Rich for doing an excellent presentation. So give him a round of applause.
Thanks.
I think this is the second time we've had you speak here, right?
In this room.
Third or fourth.
And a couple times in that room up there.
At Google.
Well, there was that too, yeah.
Okay, so not your first.
Sun campus.
All right, and we need to give away an IntelliJ license to one lucky member of the audience. Now, like any good user group, we have a very equitable system for giving out prizes. So who needs it the most?
Who will actually use it?
Who will actually use the IntelliJ license who doesn't already have one for work or from a previous jug meeting? Anybody?
Darn thing is, I got one.
Yeah, apparently you actually that's your primary IDE.
That's my primary IDE.
Switch back finally.
Yeah, IDEA. IDEA is my primary IDE.
Are you still
I
on?
got Ultimate.
Are you still on talking terms with the prog team?
Yeah. We do our best to help them.
Okay, come
Yeah,
on.
like I say, the NetBeats Gradle Sport's really nice.
Nobody's jumping. Me, I want the license. You're
Somebody online-
considering.
Somebody online wants it, actually.
Oh really? Who?
E. Smith.
Eric Smith. All right, sold.
That sounds good to me.
Sold to Eric. I think we've created one OpenJFX contributor because he's going to try the IntelliJ project creation.
All right, good.
Yeah. So that'll go to good use. All right. So thanks everyone. We should still have food and cookies outside. Help yourself, and you can mingle around for a while because it takes us forever to rip down the video equipment. So thanks for coming.
Thanks, Steve.
Thanks for presenting.